Hey everybody, welcome to day 16 of our 100 days of Go. Now today what I wanted to do was focus on string methods. So we did do strings before and we talked about like reversing and joining and splitting and all that stuff with strings. But there's a lot more you can do with strings. So I thought I'd spend a little bit deeper treatment of what's available for strings in Go and in Rust. So let's head over to our Rust files. Okay, so let me open up the run.go. Okay, and then basically there's a lot of different functions for strings that are built in to Go. Now a couple of cool things you can notice here. So you notice that we could actually give what we import a namespace here. Instead of having to type in string, 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 strings, you notice we could put a variable name right before the import, and now it's available there. So see, we're using strings.contain, strings. Okay, and another cool convenience is they stored the print line function in a variable, so that way it just becomes p. Okay, so just some ways to kind of set your code up in a more convenient way to write. So let me just clear all this out. Boop. Boop. Okay, don't need the encoding JSON library anymore. And I do want the strings library, except we're going to call it S. Okay. And what we're going to do is also, I forgot, did we do that inside or outside? Yeah, because we can't do it outside. Okay, just want to make sure. Okay, and I'll just do var p equals fmt.println. Okay, that's pretty convenient. Okay, so let's create a string. So let's say stir equals hello, I am Mario, or hello, it's me, Mario. Okay, and again, undefined string, so I gotta make sure I use the walrus operator, so that way it's an implicit. Cool, so we got a string, so let's take a look at the different methods. We have contains, which is going to allow us to check to see, like, does the text contain the particular string. So for example, let's p the result of s dot contains, and then we're going to pass in string, and the question is, does it contain Mario? Okay, and now let's run that code. Okay, so I'm going to open this folder up in terminal. Then again, it's like go run that go. True. Okay, so that function works. Let's try another function, count. Okay, this will count how many instances of a substring exist. Okay, so in this case, let's see here, what do we want to count? Let's count the e's. Okay, so count, and let's just count how many e's are in there. 2. There are 2 e's. Yeah, that is correct. Okay. Has prefix, this is going to check like whether it starts. Has suffix checks whether it starts or begins or ends in a particular string. So if I were to do prefix, it's like, does the string start with cheese? I don't think so, but let's find out. And what is it like? Oh, has prefix. Okay. Has prefix. There we go. Let's run the code. And false. Okay, so you get the idea there, so I don't need to do has suffix. Index. It'll tell you which index in the string a particular item is located at. So I can say index. Okay, and the index, I wanted to say, what is the index of the apostrophe? Okay. So what is the index of the apostrophe? And it's index 9. Okay, join, we've done join before, where you join it into a string. So you're saying, hey, I want to join this string with this string, and it returns a string. Repeat is if you want to repeat a string so many times. So I want to say, like, hey, I want to repeat, you know, a Let's see here, repeat A, then the number. So we'd say A, and let's make sure again we want to do the repeat method for function A, and we want to do, let's say, 26 times. Okay, and we'll just comment this out for now, since I'm not going to use it for this go around. So see, it works. Okay, replace. This is like if you want to replace stuff in a thing. So like replace 4 arguments, replace foo with O, 0 with -1. I'm assuming that's what that means. Foo. Let's see here, a little bit more detail on the replace. I guess we'll just try replace. I mean, assuming that's what I would do. Saying, okay, okay, so I'm saying here's a string. Anywhere there's this, replace it with this is what I'm assuming. Actually, let's just try that example out. That's probably the easiest way to do that and be clear about what it's doing. So let's just comment that out again. And I will paste this example. Yep, okay, so it's just basically saying, yeah. So in that case, if I wanted to use my string here, I'll say this is the string I want to do replacement in. Okay, I want to replace any instance of the letter, let's say I want to, actually let's see if I can replace a whole like substring, hell with n. Okay, and then it needs one more argument, so we'll just put the -1. I'm not sure what that's doing for me, but let's see what it doesn't like. So let's see what the error is saying. Undefined stir. Oh, that's right, I commented this out, so let's bring that back in. Cannot use 9. Oh, I wrote it as a string. There we go. And let's see what the result is. No, it's me, Mario. Okay, so it works. Okay, so that's a thing you can do. Okay, now let's see what's the difference if we do it with 1. Let's try, actually, let's see if there's a difference there. So there's no difference, but let's just see something that would replace more than once. Say in E. Okay. Hello, me. Okay, so if I do 1, it only replaces the first instance. If I do 2, does it replace 2 instances? It does. And if I do a -1, I'm assuming it does all instances. Okay, yep, okay. So that is loud and clear. Split, we've done that. To lower and uppercase, that's pretty straightforward. It just makes a whole string lowercase with a whole string uppercase. Length is going to give us the length of a string. It's always len and the thing you want the length of. Kind of like in Python. And car, if you just want to get one character of the string, it's just like an array. So that's pretty straightforward. So that's a nice set of tools. Pretty straightforward to use in Go. Again, one of the things I like Go is that it's you know, you get that compiled language, you get that extra speed of a compiled language, with a little bit more, you know, a little bit more memory efficiency with typing and some other benefits. But you know, it's not quite as memory efficient as Rust, but it's a nice sweet spot where like it's not horrendously like tricky to kind of like do the code. Like it's not that much harder. It's pretty easy to code and Go relatively. It has its nuances, but Rust on the other hand is pretty tricky. But again, it has such a great errors that really kind of tell you what you need to do. Okay, so again, here's like that string struct in Rust. Okay, so the string struct has several methods. So if we go back to the top, so again, we got the string struct. So let's head over to Rust. Okay, so I'm going to go to my singular Rust file. Okay, don't need this. Okay, and I'm going to get rid of this. So here we're going to create a string. So we'll just say let my string, or before I start complaining about camel case, my string which is going to be a string equal a string from hello, it's me, Mario. Okay, so we have a string. Okay, so there's our string in Rust, because again we have to like declare it using that, because a normal string is not necessarily mutable or borrowable. It's not as flexible as using the string struct. Okay, so we created a string literal using from a standard string by using that string from method. Okay, and because we're using the string struct, we have all sorts of methods. So I can like pop and push, which is pretty straightforward. If you've used pop in any language, it just like removes the last letter. So here's what we'll do. We'll just do print line, and then we'll just do this, and we'll do my string. Although I probably want this to be mutable. Does it mutate the original? Yes, it does. So I need this to be mutable. So let's make the string mutable, meaning I can change it. Okay. Cool. So we have those two lines to display my string. So down the middle, we'll just use the method. So my string dot pop. Pretty straightforward there. That's not bad at all. And that should remove the very last letter. So, well, we're still in the Go folder. So let me open up this Rust folder. And again, in Rust, we need to first compile it, Rust C, run.rs, and then we're going to run the file, because I'm not in the cargo project, /run. Hello, it's me, Mario. So again, it bumps off that last letter, so that worked. Okay. And then we can push a letter. So if I were to make this push, and let's say put S, although it doesn't say push, push. Try that again. Did car found at string. Okay, let's just see here. Where's the push function? It's gonna be right after that. Remove push. Ends a given character. Oh, okay, so you have to use single quotes to make sure it's a car. That's the ticket. So this is why I do this, because again, this is as much for me as it's for you guys watching. I wanted to get better in Go and Rust, so I'm doing this to force myself to just practice every day, and at the same time create content for the channel. That's not necessarily a bad thing, but this is kind of, you know, forcing me to just kind of get better, force myself to play with a lot of these more fundamental ideas instead of like I've done building an API in Go and Rust. But there were, like, especially in Rust, it was like terribly difficult because, again, I don't have the necessarily same level of fundamental knowledge. So troubleshooting things was a little bit more touch and go, you know, a lot more experimentation because I just didn't know what certain syntax was referring to. This is allowing me to kind of clarify a lot of things that, you know, luckily you have a great error tool in Rust, so I was able to kind of manage, but this will just make my life easier and make me feel much more nimble in Rust. Go, I feel pretty okay in. Okay, my string.push s, there we go. So let's try that out. And there you go, it's me, Mario's. Okay, so let's see here. With capacity, try reserve, try to see if anything sounds good. Truncate, that should just get rid of things. So again, string from, truncate to, so that's just gonna get rid of 2 letters. So let's try that out. So if I say truncate, and I say 2 letters. Okay. Truncates it to 2 letters. Okay, so it got rid of everything except 2 letters. Okay, yeah, because truncate usually just means like get rid from the back. That's right. Okay, that makes sense. String 2. String is the capacity of the string with a lower bound. The capacity will remain at least as large as both the length and the supplied value. How's this different than truncate? Let's see. So we have a string from foo. Okay, s.reserve 100. Okay, so I'm assuming that means like reserve like 100 spots, so that way you can extend the string later. S capacity is 100, shrink to 10, so that shrinks it to 10 spots. And then you can shrink it to 0. Okay, so let's just see what happens if I do that. Shrink 2. Let's just shrink it to 2 spots. Should kind of have the same effect, I'm assuming. Okay, so let's see here. Shrink 2. Use of unstable library feature. Shrink 2. New API. Ah, okay. This is a nightly only experimental API, but aren't I using nightly? Rust C version. I'm not sure. I think maybe in cargo I'm using nightly, but rust up version. Show the active install toolchains. Rust up show. I have stable default. Okay, so yeah, I guess right now I'm defaulting to stable, so that's the deal. Okay, I can change that later. Okay, so again, always pay attention for that. Like, you know, some functions are like newer functions that are not like in the stable version of the language yet, so they'll generally have like this little marker there. Okay, so far most of these methods are pretty straightforward to use too. But yeah, so let's see here. We just did shrink 2. Let's see what retain does. Retains only the character specified by the predicate. Okay, so if you only want to get rid of everything but a particular thing. So let's see here. Foobar. Cert s equals foobar. Oh, actually retains only the character. In other words, it removes all characters C, such as. Okay, so it removes the character. So if you want to just get rid of, in this case, get rid of all these underscores, that's pretty straightforward. C, where C does not equal. Okay, so this is a callback, kind of a callback method. You pass it in like a arrow function, or at least like the equivalent in Rust, and basically if it evaluates to true, if it returns true, then okay, that's cool. It's like a filter on a string, basically. New, let's just create a new string. Insert, I'm sure that, yeah, that just inserts a character where you want it. Drain, what's drain? Creates a draining iterator that removes the specified range in the string and yields the removed characters. Note, the element range is removed even if the iterator is not consumed until the end. Okay, so let's just take a look here. A is the alpha, B is the beta, beta is offset, find B. Okay. Remove the range up until B from the string. Okay, drain, beta offset, T, S. Got it. Okay, so it returns what was removed. So you remove whatever you want to remove, like a range based on indices, and then that gets returned and removed from the original string. So now you have 2 strings split up. Okay, that is cool. And these always these as functions are the converted to things. So like as a str, as a mutable vector, so that would turn into a vector of characters, I'm assuming. Returns a mutable reference to the contents of the string. So it's safe because it does not check that the bytes passed into it are valid UTF-8. As bytes, returns a byte slice of the string's contents. To invert, the inverse of this method is from UTF-8. So you can turn it into bytes and then turn it back into UTF-8. Split, replace, split once, split terminate, a lot of splits. Okay, trim end. Okay, but pretty straightforward. Like, again, this is not so bad either. So working with strings in Rust ain't too bad either. So it's just like all that iterator stuff. Okay, well, I'll leave it at that. I'll see you all later. You have a great day and enjoy. Go practice.